So this is the progress check review for quarter one for pre-calculus. So this is number one here. 5 hours, so is 5 greater than 5? No. But 5 equals here, so I'm going to plug 5 in to that part of the piecewise function. And that would give him $40 that he would charge. Is the function continuous at x equals 5? So I'm going to look in my calculator and see if these pieces are the same value at 5. I'm going to do second table to get to my table of values. So at 5, the x plus 40 is a value of 45, and the 2x plus 30 is a value of 40, so it is not continuous. Okay, well, D, it's not. Okay. What are the 3 types? There is a removable whole, and that graph looks something like this. There is a jump, and that looks something like this. And there is infinite, which is the same as a vertical asymptote. So let's say that's like this. So number 3, we've got yard work, fee for yard work, and x is hours. So 8 hours is this bottom function. Sorry, my pencil keeps breaking. Okay, 8. So this actually is negative $2, which doesn't make sense. So we should have written a better equation for the review. Sorry about that. In class, maybe we'll tell you to change part of the equation. So is it continuous at 8? So let's see. For what we've written, 25 plus x and negative 18 plus 2x. If I go to the table at 8, they are not the same y value. So no, not continuous. Oh, I didn't answer. Okay, sorry. Is f continuous on its domain? We said no. So why, or how come? So let me go back to this one. Sorry about that. I misread the question. Explain the answer using definition of continuity. The y value for x plus 40 does not equal the y value at 2x plus 30. So there is a jump, discontinuity. And it's going to be the same reason for number 3. There's going to be a jump at x equals 8. All right, find g of f of x. So this is saying g of f of x. So that's g of the square root of x plus 10. So I take the square root and I plug it in to the g function anywhere there's an x. So that's the square root of x plus 10 squared minus 10. I need some extra paper. So if we simplify that, the square and the square root eliminate each other. We get x. So now I'm going to do b, f of g of x. I would go get another pencil, but I can't pause the video recording once I start since I'm on my iPhone. So you all will just have to deal with my lead breaking and me having to fix it constantly. So x squared minus 10 goes in for this x. And that becomes the square root of x squared, which is x. Are they inverses? Yes, because f of g of x equals x, and g of f of x equals x. Sorry, you couldn't see that. So the x squared minus 10 gets placed into this x here. All right, number 5. Let me move my camera so maybe you'll be able to see more. Okay, 5. Consider the functions, find the rules for f of g and g of f. All right, so f of g of x is f of, don't let the fractions freak you out. So this gets placed into this x. Now we have to simplify, so the 6 gets multiplied. Oops, I forgot the plus 5. To both pieces of the quantity, so that's x minus 5 plus 5, which is x. Now we go the other way, I'm frustrated. Okay, g of f of, I give up. Hang on. All right, there's no pens in this room, no pencils, but I got a pen. I'm not dealing with that pencil anymore. There's too many review problems to have that keep breaking. G of f of x, so that is g of 6x plus 5. So the 6x plus 5 goes in for this x. And I multiply, so that is x plus 5/6 minus 5/6, which is x. Because they both equal x, they are inverses of each other. Okay, algebraically, numerically, or graphically, even is y-axis symmetry, odd is origin symmetry. So algebraically is the hardest way by plugging in x and negative x. I'm going to go with numbers and graphically. So for this first one, f, I'm going to plug in 4 because I can actually square root it, and negative 4. Well, the square root of negative 4 is imaginary. These are not the same, so this is neither. If we look at it, Zoom 6 is a nice 10 by 10 window. It's just in the first quadrant up here, so there is no symmetry. All right, for G, let's plug in 4 and negative 4 and see what we get. Notice I have an older calculator, so I have to put parentheses around my exponent. Oh, undefined again. Where this one had a number. Sorry, I didn't write it down. So this is neither. Let's look at it, just to be safe. X to the 3/4. Again, with the parentheses around the exponent. Still the first quadrant, no symmetry. All right, x to the negative 4th. Let's start graphically. Oh, see how it's symmetrical on the y-axis? So this is even. Now let's prove it with numbers. H of, let's do 2 and negative 2. So 2 to the negative 4 and negative 2 to the negative 4. They're the same value, which is why we have even y-axis symmetry. Okay, let's do J. I'm going to do J of 2 and J of negative 2. Oops, there we go. So 2 to the negative 1/3. Make sure you type correctly on your test. And negative 2 to the negative 1/3. So those are opposite values. So the signs are opposite, so it's odd. Let's look at the graph just to double check. And we have that origin symmetry. Another way to think of origin is if you rotate 180 degrees. So this looks the same as that. All right, which best describes the symmetry of 6? Cool, let's graph it because it's multiple choice. I have no work that needs to be seen. Now, if this was the progress check and it was a free response like number 6 was, showing some work is helpful. If you do it graphically, you should draw the graph for whatever we saw. This one is odd. It looks the same this way as if I go that way. It's B. All right, accurately graph. Ooh, and it's so nice. We give you the factored version and the unfactored. But you know what? I like the numerator. When it's squared, it means times itself. There's a hole. And the value that makes this factor 0 is -3. When I plug that into the simplified version, so now my equation is x plus 3 over x plus 1. When I plug -3 in here, ooh, we get 0. So at -3, 0, there's a hole. Ooh. The vertical asymptote is what makes the denominator 0. So x equals -1. The horizontal asymptote is when I compare my degrees. They're the same, so I divide my leading coefficients. There is no slant asymptote. All right, so let's see what this looks like. When you type this in your calculator, you must put parentheses around the numerator and parentheses around the denominator. And I chose to do the original because I'm going to show you if I hit trace and go to -3, see there's no y value. It's missing there. So what I did is, oh, you couldn't see me typing the buttons. I did trace -3, enter, and it puts our cursor at that spot. So to graph it, we've got a vertical asymptote at -1. You should always graph them with a nice dashed line. Our horizontal asymptote is at y equals 1. This goes down here, and this p, oh, what's the y-intercept? 3. Goes up here. So I wanted to put the y-intercept just so I could have the most accurate graph, because it says accurately. Gotta be accurate. All right, another graph. Nothing cancels, no holes. Vertical asymptote is what makes the denominator 0. The numerator degree is higher than the denominator, so there is no horizontal asymptote. There will be a slant. So we have to divide. I'm going to use long division. I'll also do box method for those of you that like box. I like to hold my spot, anything that's missing. So I do x squared divided by x is x. Multiply it back, subtract, bring down. X divided by x is 1. Multiply it back, subtract. We don't care about the remainder. So our asymptote is y equals, because it's a line, you need to write y equals x plus 1. So I can graph my vertical asymptote easily at 2. I can graph x plus 1. That's the y-intercept of 1, up 1 over 1, up 1 over 1. So you could graph the slant asymptote. We're not going to ask you to do that on the progress track. But let's look and see what this looks like. So here we approach the asymptote, go through the origin and down, and then it's this piece up here. All right, number 9. We factored the denominator. Nothing cancels, so there's no holes. The vertical asymptotes are at x equals -4 and x equals 3. And since the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is at y equals 0. So there is no slant. All right, -4, 3, 0. Let's look at it. I'm so glad I changed out my breaking pencil for a nice pen. I hope I make no mistakes. Nobody's perfect. Whoa. All right, so this piece is down here. Does that go through the origin? No, close. So 0 is underneath it. Let's see some negative, let's see. Negative, these are really tiny, so it goes like this. That's this piece here. And then, so asymptotes, the horizontal asymptote is only for end behavior. You can cross it in the middle of your graph. Okay, number 10. Well, we got a calculator, might as well use it. Let's do x to the 3/2, x to the 1/2, x to the 4/3, and x to the 2/3. Now, if you have a nice new calculator that graphs in color, that's awesome because you will have a way easier time than me in my boring old gray and green calculator here. Notice we only gave you the first quadrant, so we're ignoring whatever's over here. Now watch this. If I hit trace, move my cursor over a bit, it tells me which function I have in this upper right hand corner. So this first steepest one, A, is the 3/2, so that's this one, A. If I hit the down arrow, it moves to y2, and that's my least steep one, so that's D. D. And if I hit the down arrow again, it goes to y3. Oh, too far over. See how this is off the screen? All right, so it's the second steepest one. This is B, so that leaves that for C. Which function increases the fastest? That would be A, so F. Oh, they're all x to the 3/2. This one's increasing the fastest. Fractions. All right, number 11. To add A together, I need a common denominator, but first I have to factor. So my least common denominator is going to be both of these multiplied together. So my left term needs an x minus 2. So I get 2 times x minus 2 plus x minus 3 over my common denominator. And then I'm going to simplify. This is 2x minus 4. So we get 3x minus 1, because -4 minus 3, over x plus 2x minus 2. For B, my common denominator is going to be 4 times x minus 3. So this is missing a 4. This is missing an x minus 3. So we get x times x minus 3 plus 8, 2 times 4. And I'm going to distribute that, so we get x squared minus 3x plus 8 over 4 times x minus 3. For C, my common denominator is going to be x times x plus 1. So this needs an x, and this needs an x plus 1. So we get 3x plus 3, because I distribute the 3 to both, minus 2x. 3x minus 2x is x. And that's our answer for C. Ooh, D has a lot of factoring. So what multiplies to 6 that adds to -5 is going to be -2 and -3. And x squared minus 4 is going to factor to conjugates, x plus 2, x minus 2. So this is going to have a long least common denominator. It's going to be x minus 2 because they both have that. It's going to be x minus 3 because the left term has that one, and then x plus 2. So the whole common denominator is all 3 of those factors. So this term is missing the x plus 2. And this term is missing the x minus 3. So we have 2 times x plus 2 plus 5 times x minus 3. Sorry, you couldn't see that. And then I'm going to distribute, so that's 2x plus 4. That's 5x minus 15. So 2x plus 5x is 7x, and 4 plus -15 is -9. No, it's not. It's -11. -11. Don't be afraid to use your calculator. All right, and last but not least for E. The least common denominator is going to be 2x squared, because I need this 2 and we need this x squared. So this term is missing an x. This term is missing the 2. So here we're going to have x squared plus 4x. Here we're going to have minus. So this -2 is what gets distributed. That's minus 2x plus 2. And we can combine these like terms. And there's our answer. Write as a single expression. So here the common denominator is going to be p times p plus 6. Make sure your p's look like p's and not 9s or some other number. So this term is missing a p, and that's it. Oh, excuse me. So we get 5p minus 1 plus 2, which is 5p plus 1. This can factor. So that's my common denominator. This is missing x minus 4. This is missing x minus 2. So we get x squared minus 4x when I distribute that, plus 3x squared minus 6x. There's a negative here, so I'm going to do minus 32 plus 2x. This negative has to go to both terms. Okay, in the numerator, x squared and 3x squared is 4x squared. -4, -6 is -10, plus 2 is -8, and -32. Ooh, that can factor. Let's see what happens when we take out a 4. Does anything multiply to 8 that adds? It does. It can keep factoring. Whoa, this is crazy. Okay, so we've got 4. -8, what multiplies to -8 that adds to -2 is -4 and +2. And look at this, these eliminate, they divide to 1. So our answer is 4 times x plus 2 over x minus 2. If I had factored out a common factor up here, the 32, if I had make that 2 times, oh no, that wouldn't factor. Well, I mean, it factors, but nothing is going to cancel. Never mind. And number 13. Oh boy, that's a lot of stuff. Okay, here we go. This is 4 questions in one with multiple parts. Graph it. Use your calculator. I'm going to factor everything here. What multiplies to 8 that adds, oh, -4 and -2. There's a hole. At +2 something. So our simplified equation is x plus 2 over x minus 4. So when we substitute 2 in, we get 4 over -2, which is -2. Vertical asymptote is at x equals 4. And the horizontal asymptote, the degrees are the same, so we divide the leading coefficients. All right, now I'm going to sketch a graph. X equals 4, y equals 1, 2, -2, down here at the hole. You could look at it in your calculator and see a beautiful graph. For symmetry, the bottom, there's none. I can see that by the graph. It's been shifted. It's away from the origin. All right, next one. Let's factor. We get x plus 2 times x plus 2 over x minus 3. No holes. Let me see if I can move my phone up a bit so that way you can see the whole problem. Sorry. Hope I'm not making you dizzy. All right, did that work? Yes. Okay. What makes the denominator 0 is the vertical asymptote. When I look at my degrees, the top is bigger, so there is no horizontal, but there will be a slant. Oh, I forgot to do box method on the other problem. Darn. I'll do box method now for you box people. All right, we gotta divide. Here's how box method works. X, -3, x squared, 4x, 4, x squared. So then x squared divided by x is x, multiply, subtract, divide, multiply. I don't care about the remainder. Here is our slant asymptote of x plus 7. Because I'm remembering now, I will do long division. I'm so sorry I didn't do that other one with box method. X squared divided by x is x. Multiply it back. Subtract. Bring down. Oops. Divide. Multiply it back. Don't care about the remainder. Here's your slant asymptote. It's not going to have any symmetry because x plus 7 is the slant here. X equals 3. Let's figure out which pieces. There's our, all right, so bottom left, and can't even see the top piece and the top right. That goes here and up here. For this one, the denominator factors to x plus 2, x minus 2. So my vertical asymptotes are at x equals 2 and -2. No holes. Nothing, none of the factors cancel. The degree in the numerator is smaller than the degree in the denominator, so it's y equals 0. So we got 2, -2, 0. Let's look at it. We've got this piece, and this piece. I wonder if that has y-axis symmetry. Why would I go to -1? What? Trace -1. 1.666. If I do trace 1. Nope, not the same. Okay, so for symmetry, if I tested 1 and -1, and it's easier if we look at the table. So -1 is 1.6 repeating, and +1 is at 1. These values are not the same, not even the same number with different signs, so again, it's neither or no symmetry. And last but not least, on the entire review, that's so exciting, the numerator factors to x minus 3, x minus 3. The denominator is a difference of 2 squares. Oh, we got a hole. The x value that makes the canceled factor 0 is 3. So our simplified equation is x minus 3 over x plus 3. When I plug in 3, we get 0 divided by 6, which is 0. For the vertical asymptote, it is when the denominator equals 0 at -3. The degrees are the same. So we divide the leading coefficients, no slant. Now for symmetry, well, let's graph it. -3, 0. Nope, it's not gonna, and then over. Oh, y equals 1, sorry. Here's our hole, so we're gonna have this piece and this piece. That has no symmetry. None. And that is your entire quarter review.